Hi, my name is dr. Ahmath. Welcome to the course of Probability and Statistics. In this lecture, we're going to talk about the hypothesis test. This is essentially our introduction to this topic. In this lecture, we're going to discuss the general concept of the testing the hypothesis, and also we're going to introduce the basic notations and the definition. In particular, we're going to talk about what is the null hypothesis, alternative hypothesis, what is the plausibility or the p-value of the hypothesis, and what is the level of significance of the hypothesis. So you probably have seen this kind of hypothesis before when the manufacturer claims that their batteries, the rechargeable batteries, are good for at least 1,000 charges. Or the Federal Aviation Administration claims that average weight of the passengers is 88.45 kilograms. Or the Statesville College claims that 94% of their graduates find employment within 6 months. Whenever you see this kind of claims, you probably should know that this is the hypothesis. So the hypothesis basically means that it is not possible to prove this. When the manufacturer claims that their batteries are good for at least 1,000 charges, it means that they are estimating this number. So they don't know this for sure because it is not possible to track every battery which they are selling and count how many times it is working, right? It is charging. And they are making some estimation, the point estimation in this case. So, or the Federal Aviation Administration is also making some estimation. Previously, we've learned about how to make this kind of estimation. We can create point estimation, or we can create the interval around this point estimation, which we are going to call as a confidence interval. In this part of this course, we're going to discuss how to test this kind of estimations. And this process of testing the hypothesis is called the hypothesis test. And essentially, we're going to test this again in the same, more or less in the same way as before. We take a sample from the population, calculate some numerical values of the sample, then make our conclusions about the hypothesis. So if you remember, the parameter is the numerical value of the population. The parameter of the mean is going to be denoted as a mu. For the variance is going to be sigma square. For the proportions is going to be p hat. So overall, this lecture, we are going to try to build our algorithms and the concepts for the population mean. And later on, we're going to generalize those ideas into the population variance and the proportions. But you should know that the general concept and the picture is going to be more or less the same for all of this parameters. And again, so our general idea is if I would like to test the hypothesis test about the population parameter, I'm going to take a sample from the population, calculate so-called test statistic, some numerical values of the sample. Then this test statistic is going to tell us something about the plausibility of the null hypothesis. So, well, the plausibility of the null hypothesis basically means how probable this null hypothesis. It is numerical value which is going to tell me how probable the null hypothesis is. We are going to talk about the two different types of the hypothesis. One is called the null hypothesis, when the statement that so the null hypothesis is a statement that the value of the population parameters, such as mean, proportion of the variance, is equal to the claimed value. For example, the null hypothesis might be when the proportion is equal to the 0.5 or 50%, or the mean is less or equal than 11.5, or the mean is more or equal than minus 33.5. Basically, if you see in your claim or in hypothesis equality sign, like equal, less or equal, or more or equal, then you should know that this is about the null hypothesis. What if you don't see the signs? If you don't see the signs, it means that your hypothesis is alternative hypothesis. So its alternative hypothesis is like opposite to the null hypothesis, and we're going to have only more sign, greater sign, less sign, or non-equal sign. So the alternative hypothesis for this one is going to be p is not equal to the 0.5. Alternative hypothesis, for example, for this one, when the mu is less or equal than 11.5, is going to be simply mu is greater, strictly greater than 11.5. And for the last one, when the mu is greater or equal then minus 33.5, the alternative hypothesis for that is going to be equal to the less than minus 33.5. So the null hypothesis is kind of the complement to the alternative hypothesis. And later on, we will see that, hey, if the null hypothesis is true, the alternative is going to be false, and vice versa. So it's basically, so we are mathematically, we are always going to, okay, so let's do a couple of examples. So a manufacturer claims that its rechargeable batteries have an average lifetime at least 1,000 charges. So we are going to write down the claim mathematically. We're going to write down the null hypothesis and alternative hypothesis. So the claim tells me that the mean, the population mean, should be at least 1,000, right? More or equal. So this is going to be our claim. So our claim actually, so the null hypothesis should use this sign, right? So this is actually the null hypothesis, and the alternative hypothesis should be the opposite. Means that the mu is less than 1,000. So in this case, our claim is the null hypothesis. So if I test my null, okay, so later on you will see what I mean. So it's basically very important to identify what kind of hypothesis your claim is. Either this is the null hypothesis or the alternative hypothesis, but at the same time, it's also important to write down what is the null hypothesis, alternative hypothesis. So we need to write down the three things always algorithmically in order to test the hypothesis. Let's do another example. The Statesville College claims that more than 94% of their graduates find employment within 6 months. Again, we're going to write down the claim, the null hypothesis, and the alternative hypothesis. More than 94%, it means that the proportion is going to be more than 0.94. So what type of the hypothesis is this? So in this case, it's going to be the alternative hypothesis because it doesn't have the equality sign, right? So then the null hypothesis is going to be its opposite. Basically, it's going to be less or equal to 0.94. So in this case, we wrote down what is the null hypothesis and alternative hypothesis for our claim. And also we identified that our claim actually is the alternative hypothesis because it doesn't have the equality sign. So no matter what is your claim, whether it is the null hypothesis or alternative hypothesis, we are always going to test the null hypothesis. For example, you wrote down your claim mathematically, then you identified that this is the alternative hypothesis. At the same time, you wrote down the null hypothesis of this by finding the complement of the alternative side, right? So you always can write down the null hypothesis for the claim, even though that this is not a null hypothesis. Then we are always going to check the null hypothesis. So mathematically, we can check this. Let's assume that we know for a while how to do this. And after we check this, we are going to either reject the null hypothesis, either do not reject the null hypothesis. So either we fail to reject the null hypothesis, either we reject the null hypothesis. So for example, in our example, in the previous example where the proportion was more than 0.94, it was the alternative hypothesis, right? So what to do in this case? So how we are going to make our conclusions? Because this part of the slide tells me that, hey, you need to test the null hypothesis, then decide whether you are going to reject the null hypothesis or fail to reject the null hypothesis. Well, in this case, I'm going to test the null hypothesis. Always, we're not going to test the claim. We'll always write down the null hypothesis and always write down the test the null hypothesis. So in this case, if the null hypothesis is rejected, then the alternative hypothesis is not going to be rejected, right? It's going to be supported because the alternative hypothesis is the opposite to the null hypothesis. But if for this kind of claim, the null hypothesis is failed to reject, it means that the null hypothesis is okay. But if we need to test our claim, which is the alternative hypothesis, we are not going to support the alternative hypothesis. So basically, we're always going to test the null hypothesis, and then we can create the conclusions about the alternative hypothesis as well by just taking the opposite conclusions, right? So as it is here. If you reject the null hypothesis, then its opposite, which is the alternative hypothesis, is going to be supported. So if they fail to reject the null hypothesis, then its opposite is not going to be supported. So now we know what is the null hypothesis and alternative hypothesis and how to create them for the given claim. So now we are going to learn how to make the test and write down the conclusions. And essentially, no matter what is our claim, whether it is the null hypothesis or alternative hypothesis, we are always going to test the null hypothesis. So after the testing of the null hypothesis, we are either going to reject the null hypothesis, either fail to reject the null hypothesis. What if our claim is the alternative hypothesis, as in our previous example? For example, you've got a proportion which is more than 94%. It is the alternative hypothesis, right? And we build the null hypothesis for this claim. So the null hypothesis claim says that the proportion is less or equal than 94%. Then we tested this null hypothesis, and we assume, for example, you might get one of these two conclusions for the null hypothesis. But what about the alternative hypothesis, which is our claim? So since the alternative hypothesis is the complement of the null hypothesis, then our conclusion should be more or less opposite to our conclusions about the null hypothesis, right? For example, if you've got the conclusion about the null hypothesis that you have to reject the null hypothesis, then its opposite, which is the alternative hypothesis, should be supported. If, for example, you test this the null hypothesis and you are not going to reject this, so it means that you fail to reject this, it's okay with the null hypothesis. It means that its opposite, which is the alternative hypothesis, should be rejected, right? Or should not be supported. So in general, just testing the null hypothesis is enough for us to know everything about the alternative hypothesis as well. So we need to build a table which basically is going to tell us what to do depending on our test results about the null hypothesis. So we're going to talk about when our claim is a null hypothesis and alternative hypothesis, and when our result about the null hypothesis is going to be rejected or do not reject. If, for example, your claim is a null hypothesis, and if the null hypothesis during your test is rejected, then you are going to reject the claim. If your claim is alternative hypothesis, then you are going to support your claim. So if you tested the null hypothesis and you fail to reject the null hypothesis, then if your claim is the null hypothesis, then you are going to support this, or you're not going to reject this. If your claim is alternative, and if you fail to reject the null hypothesis, it means that you're not going to support this. So you see, so the keywords of the conclusions for the null hypothesis is reject or do not reject. And the key word for the alternative hypothesis is always going to be the support. Either we support this, either we're not going to support. And the conclusions about the null hypothesis is either we reject this, either we are not going to reject this. So in terms of the words, writing down the conclusions in terms of the words is a little bit confusing. So you need to try to remember this using the keywords. For example, rejection of the null hypothesis is there is enough evidence to reject the claim. When we are not going to reject this, we just usually write there is not enough evidence to reject the claim. Whenever we support the alternative hypothesis or the claim, we usually write there is enough evidence to support the claim. And when we are not going to support this, we usually write there is not enough evidence to support the claim. So structurally, they look actually similar, right? So you need to use not and not here to this column, and we don't have not in this column. So just use this table in order to figure out how to write down the proper conclusions. But actually, so everything is more or less logical. So now, for example, a cigarette manufacturer claims that less than 1/8 of the US adult population smokes a cigarette. So we first of all need to write down this claim as a mathematical sentence, right? So it means that the proportion is less than 1.8. What kind of hypothesis is it? So this is the alternative hypothesis because it doesn't have the equality sign, right? So in this table, we actually need to look to the second row, right? Because our hypothesis is the alternative hypothesis, and we need to make the conclusion about the alternative hypothesis. You, for example, took a sample statistic, you took a sample and calculate the test statistic and do your calculations, and after you have calculations, you decide to reject the null hypothesis. So it doesn't mean that you have to reject your claim because your claim is the alternative hypothesis. So you are going to support this if you reject the null hypothesis. You write down, hey, there is enough evidence to support this claim. But if your calculations tells you that you should not reject the null hypothesis, it means that you need to reject or do not support the alternative hypothesis. That in this case, your conclusion should look like there is not enough evidence to support the claim. So, and the main question actually is, how do I know what is this procedure of rejecting and do not rejecting the null hypothesis? And the main question is the procedure, how we need to know, how we need to reject the null hypothesis or do not rejecting the null hypothesis. Well, it appears it is possible to evaluate the plausibility of the null hypothesis mathematically, and this is called the p-value. So the plausibility of the null hypothesis is basically the probability that null hypothesis is true. And we are going to write down numerically, and this number is going to be called as a p-value. For example, we before have seen, we talk about the test statistics and the critical points for the samples, right? So for example, if you are going to make a confidence interval about the population mean, then you need to take a sample, calculate the mean of the sample, then a distribution of the mean of the sample is going to have the normal distribution. So this is very much similar here. So if we are testing the hypothesis about the mean, then we are going to use the normal distribution, and we're going to calculate the test statistic. We are going to talk about this technical details later on. So let's assume that you've calculated the test statistic, and then you are going to split the area under the normal distribution curve into the two parts, or maybe three. So in this case, we are going to look to when we splitted this area into the two parts. Then the p-value is going to be the area which is more righter than the test statistic if we are going to use the right TL test. The p-value is going to be the area which is more left than the test statistic if we are going to use the left TL test. And the p-value is going to be the area in both of the tails if we are going to use the two-tail test. If you use the two-tail test, we need to find out the negative value of the test statistic. We put it there. We need to split the area under the normal distribution curve into the three parts. Then the p-value is going to be the sum of the areas on the two tails. And the only question is, how do we know actually what type of the test we need to use, whether we need to use the two-tail test, the left tail test, or the right tail test? Well, it appears we need to look to the signs of the alternative hypothesis. So the type of the test depends on the sign of the alternative hypothesis. You need to always write down your claim, then you need to write down the alternative hypothesis. If the alternative hypothesis have the non-equality sign, then you need to use the two-tail test. Basically, it tells you that in order to calculate the p-value, you need to take the sum of the two areas on the tails. So if the sign of the alternative hypothesis has the greater sign, then you need to take as a p-value the right tail. If the sign of the alternative hypothesis is the less sign, that is this one, then you need to take the left tail as the p-value. So once you know what is the p-value, how do we know whether this p-value is enough, is significantly big or small? For example, you've calculated that the p-value is equal to the 2% or 0.02. How do you know whether this p-value is significant enough to do not reject the null hypothesis, for example? Or let's assume that the p-value is 0.05. Is it plausible enough to do not reject the claim? So again, the p-value is going to tell you how plausible your null hypothesis is. And this is the numerical value. So the p-value can be a number, for example, 0.5 or 0.9 or 0.05. So how do we need to decide whether this number is big enough to do not reject the null hypothesis or small enough to reject the null hypothesis? Well, it appears we need to compare this with some reference values, which we are going to call as a significance level. So usually, the standard typical values for the significant levels are 0.05 or 0.01, and we are going to denote the significant levels as the alpha. For example, So the p-value of the hypothesis test is equal to the 0.0256. If the level of significance is 0.05, what kind of decisions you're going to make about the null hypothesis? Well, we need to compare the p-value and the level of significance, right? So that we calculated the p-value, which is the plausibility of the null hypothesis. So now, in this case, this is smaller than our reference value, is smaller than the level of significance. It means that it is not enough. It's not big enough, right? So the plausibility of the null hypothesis, it means that we are not going to support this. We're going to reject this, actually. So if the p-value of the null hypothesis is equal to the 0.0256, and we need to if we need to compare this with another reference value and another significance level, which is equal to the 0.01, in this case, the p-value is greater than this level of significance. It means that our null hypothesis is plausible enough to do not reject this. So in this case, we are not going to reject this. So this is how we are going to make the conclusions depending on the values of the p and alpha. So let us write down the summary or basically the general picture and general algorithm of the hypothesis testing. So whenever you've got the claim, what you have to do is you need to write down mathematically 3 things. You need to write down your claim mathematically, you need to write down the null hypothesis and alternative hypothesis. Then this is step number 2, write down the null hypothesis and the alternative hypothesis. The step number 3 is you need to take a sample and calculate the test statistic. Depending on what type of the hypothesis we're testing, about what type of the parameter we are testing the hypothesis, the test statistic is going to be calculated differently. For example, it might be different for the mean or the proportion or for the variance. Number 4 step is we need to identify the test type and the p-value. So if you remember, in order to identify the type of the test, you need to look to the sign of the alternative hypothesis. Then you decide which areas you are going to choose as the p-value, right? So now, once you have the p-value, you have to compare this with the level of significance. And usually it is given. If it is not given, if, for example, you're doing this for your own statistical analysis, it depends really on a context. What do you think that the p-value is significant enough? For example, if the p-value is greater than the level of significance, it means that it's plausible enough, right? So you're not going to reject the null hypothesis. If the p-value is less than the level of significance, it means that the plausibility of the null hypothesis is not significant enough, so you are going to reject the null hypothesis. So once you decide what to do with the null hypothesis or alternative hypothesis, then you need to go back to our table, the huge table, and write down the conclusion about your claim. Because if you remember, if your claim is alternative hypothesis, and if you're rejecting the null hypothesis, you are going to support the alternative hypothesis or your claim, right? So in our next lectures, we're going to talk more in more details and technically how to do this, for example, for the population mean.